All right, so we're going to talk about how to write the equation of a line parallel to another line given a point. So let's look at our first example here. It says write the equation of a line parallel to y equals 1 half x plus 4 that also goes through the point 4 comma 8. And so if you're like me, when you read stuff like this, sometimes it's a little hard to picture what this is even asking us to do. So what I've done here is I've actually created a picture, and I want to actually pull that picture in and look at that picture. Okay, so what it's asking us to do here is to create a line that's parallel to y equals 1 half x plus 4 that goes through the point 4 comma 8. So what I've done here is I've actually graphed y equals 1 half x plus 4. I went up to 4, and then I went up 1 over 2, up 1 over 2, up 1 over 2. So this red line here is the line y equals 1 half x plus 4. So the goal is to create a line that's parallel to the red line that just so happens to go through this point 4 comma 8, which is this green point right here. So just to do a rough sketch of this graph, it's probably going to look, roughly like this, because we want to be parallel to that red line. Okay, don't quote me on that, but it's going to be something like that. So how would we go about doing that? So the first thing that I would recommend doing is when you write the equation of a line, there are generally two forms that people use. The first one is called slope-intercept form. So y equals mx plus b. This is called slope-intercept form. It's really nice if you have the slope of your line and you know what the y-intercept is, hence the name, slope, and then intercept stands for y-intercept. That's one equation that people like to use. I'm trying to get another color here. Sorry, give me just a sec. Another equation that people like to use is called point slope form. So this one is y minus y1 is equal to m times x minus x1. And this one is called point slope form. It is the lesser known, but I think, in my opinion, I think it's even better than slope-intercept form. What I'm going to do is I'm going to walk you through how to do this. You can use either method. I will show you both methods, and I'll let you pick which one you like. I personally like point slope because point slope is designed to write the equation of a line assuming that you have the slope and a point. Now the point here is x1, y1. So it's assuming that the point that you have is x1, y1. So if your point was 4 comma 8, for example, then basically what we're going to do is we're going to put the 4 here and we'll put the 8 there. Okay? All right. So with that in mind, let's do point slope first, because I want to show you point slope because I think you'll like it. Okay, so what we've got is we need to write the equation of a line, and our equation is going to look something like this. We are going to fill in the y1, the m, and the x1. When you write these, typically you leave the y and the x alone, and you fill in the m and the b for slope-intercept, and you fill in the m, the x1, and the y1 for point slope form. Okay, so when we do point slope form, I'm going to scroll down just a little bit here. What we're going to do is we're going to write y minus, and now we're going to put in the y coordinate of the point that we are interested in. The point that we happen to be interested in is 4 comma 8, which was up here. So let's actually put in 8 for the y value there, and we'll say equals m. Now we need to put in m. I'm just literally just copying this equation down here. So m, what is the slope of our line? Okay, the slope of this line, the red line, is right here. It's 1 half. Okay, and by the way, a lot of people say the slope is 1 half x. You don't need to put the x. The slope is just a number. Okay, you don't need a variable. So the slope of the red line is 1 half. I'm going to say that if we're going to be parallel to that, we need to have the exact same slope. So let's go ahead and just copy that slope, 1 half. And then we'll do x minus, and then now what we're going to do is we're going to put in the x coordinate of the point that we're interested in. The point that we're interested in is 4 comma 8. It's this green point right here. So the x coordinate there on that was 4. All right, so we'll close that off. Now, here's the funny thing. Depending on your teacher, this may be a completely acceptable answer. In fact, in my class, I say, if you put this, I'm happy with this. This is a great answer. Okay? Some teachers may want you to simplify, so, you know, or they may ask for you to put it in slope-intercept form. Now, here's what's really nice about point-slope form. If you put it in point-slope form, you can change it to slope-intercept form really easily. Just watch. All we're going to do is distribute. So we're going to take the 1/2 and multiply it out to the x and the -4. So we'll have y minus 8 is equal to 1/2 x. And then -4 times 1/2 is minus 2. And then if you just add 8 to both sides, then you're left with y is equal to 1/2 x. And then -2 plus 8 is plus 6. This right here is slope-intercept form. So what's really, really nice about point-slope form is that when you do it, you can actually get to slope-intercept form quickly and easily. Okay, so that's pretty cool. That's one option. Some of you may have learned to use the slope-intercept form, so I do want to talk about that. So let's go over that. So let's scroll back up here. If we're going to use slope-intercept form, then we're going to do y equals mx plus b. This is the equation we're going to work with. What we're going to do is we're going to utilize the fact that we know that we're going through the point 4, 8. So 4 is the x value we're interested in, and 8 is the y value that we're interested in. We're going to actually plug in those x and y values. I know I told you we leave the x and the y alone, but there is a special case here where we're actually trying to solve for the y-intercept here. So let's do this. So we're going to plug in y. We know the y value is 8. That's going to be equal to m. What is the slope of our line? The slope of this line was 1/2. So the slope of our line is going to be 1/2. That's m. The x value happens to be 4. And then the y-intercept, we don't know what the y-intercept is. That is a b. That is not a 6. Okay, so it's 1/2 times 4 plus b. Now what we're going to do is we're going to actually solve for this b. We're going to figure out what the y-intercept is. Then we're going to write the equation in slope-intercept form. It should be the exact same as what we have below. So let's do this. Let's solve for b here. 8 is equal to 1/2 of 4 is 2 plus b. And then if you subtract 2 from both sides, you should get that b is equal to -6. So b is equal to -6. So if you're going to write the equation of the line in slope-intercept form, you have y equals, and then you put the slope, which we know is 1/2. Then we leave the x alone. And then you put in plus b. In our case, b is -6, so we'll just put -6. And check this out. You get the exact same answer whether you start in point-slope form or whether you start in slope-intercept form. So join the dark side and use point-slope form. It's awesome. Okay, so let's look at another example here. Write the equation of line parallel to y equals 2/3 x minus 1 that goes through the point 6, 4. So just real quick, I'm going to graph this just so I can get a feel for what it looks like. So 2/3 x minus 1, so I'm going to go to -1, and then I'm going to go up to right 3, up to right 3, up to right 3, up to right 3, down to left 3, down to left 3, down to left 3. And we'll draw that line. So here's our line. And so what we're trying to do here is we're trying to find the line that's parallel to that red line that goes through the point 6, 4. So 6, 4 is that green point right there. So this line that we draw, this is a very rough sketch, don't judge me, is probably going to look about like that. Okay? Just so we have a frame of reference. All right. So, like I said, I'm going to recommend that you use point-slope form. So point-slope form was y minus y1 is equal to m times x minus x1. By the way, some of your textbooks or your teacher might say y not, or y with a little 0 here and x with a little 0. Same thing. All right. So what we're going to do is we're going to do y minus, and we're going to put in the y coordinate of the point that we are interested in. So we're trying to write the equation of a line that goes through this point right here. So this right here is the y1 that we're interested in, and this is the x1 that we're interested in. So when we fill this in, the y1 is 4, equals the slope. What does the slope of our line need to be? Well, if our line is going to be parallel to this one, it needs to have the exact same slope. So the slope needs to be 2/3. So 2/3 x minus, and now we need to put in the x coordinate of our point, which was 6. And now we're good. So you can either write it like this. So this can be your answer. In my class, that's totally acceptable. Or if you want it in slope-intercept form, that's fine. You can just simplify a little more. So we'll do y minus 4 is equal to, we're going to distribute that 2/3. It needs to go to the x and to the minus 6. So we're going to have 2/3 x, and then 2/3 times -6 is just -4. And so what we're going to do now is we will add 4 to both sides because we're trying to get y by itself. And we will get y is equal to 2/3 x. And then the 4's actually cancel on the left and right. So you could put plus 0 here. Or if you want, you can just put that right there. So this is point slope form of the line. And this right here is slope-intercept form. Both equally valid. They each have their pros and cons. Okay? And one of the things that's nice to do that I didn't mention on the last example is if you want to know if you're right, just go ahead and graph your line and see what it looks like. So if you actually come over and graph this line, I'll do it in blue. Let's use the slope-intercept form. So I'm looking down here. So we're going to do 2/3 x plus 0, right? So it didn't give a y-intercept, so we're going to assume the y-intercept is right here at 0. And then we're going to go up 2 over 3, up 2 over 3. Look at that. It goes right through the point that we wanted it to go through. Down 2, left 3, down 2, left 3, down 2, left 3. And you can tell that when we draw this blue line here, that it's never going to intersect the red line. So we'll draw that blue line, and yeah, look at that. Those are perfectly parallel. They're never going to intersect each other. So that's how we know that we did it right. All right, let's look at another one. How about this? So write the equation of the line parallel to 2y minus 3x is equal to 8 that goes through the point -2, 5. The only added level of difficulty that I've introduced here is I've given you the equation of the line that's not already in slope-intercept form, which is really not a big deal. All you want to do is just change it over to slope-intercept form, and you'll be good to go. So if you've got 2y minus 3x is equal to 8, then go ahead and add 3x to both sides. And we've got 2y is equal to, I'm going to put the 3x first. Some people put 8 plus 3x, but I like to have the x first because it's nice to have this in slope-intercept form. All right, now we need to divide both sides by 2. So we'll divide both sides by 2. I like to divide every aspect in there by 2. So you'll finish with, let's do purple here. You'll finish with y is equal to 3x over 2, I'm going to write that as 3/2 x plus, and then 8 over 2 is 4. Okay, this is the original line. This is not our line. Be careful. Some people get so excited and they're like, oh, I got this. This right here was the original line. So we're trying to be parallel to this. But we're trying to go through the point -2, 5. So, as I've been doing lately, let's go to point slope form. So we're going to do y minus y1 is equal to the slope times x minus x1. And let's fill this in. So y minus y1, in our case, happens to be 5. So we'll put a 5 there. That's y1. That's equal to the slope. What is the slope? The slope of the original line was 3/2. We're trying to be parallel to that. So let's make our slope the exact same. 3/2. And then x minus, and then the x coordinate of our point that we're interested in is -2 there. So we'll do -2. And notice how I put that in parentheses. That's going to be really important. I'm going to move this over so I can write a little better here. Okay, so this I would not leave it like this. If you're going to leave it in point slope form, I would write y minus 5 is equal to 3 halves x, and then since it's minus negative 2, I would put plus 2. If you're going to put it in point slope form, I would answer it and leave it like that. That's fine. If you have to put it in slope-intercept form, then we'll solve it out. So y minus 5 is equal to, I'm going to do 3 halves times x and 3 halves times 2. So we're going to distribute that here and there. So that's going to be 3 halves x plus, and then if you do 3 halves times 2, that will give you 3. So if we add 5 to both sides, then what we get is y is equal to 3 halves x. If you have 3 plus 5, that's plus 8. Okay, so this right here is going to be our slope-intercept form. So this is our point slope form. And this is our slope-intercept form. Both equally valid. Let's look at another example. Number 4, write the equation of the line parallel to y equals 5 that goes through the point 2, negative 1. So this one's weird because normally we're used to y equals mx plus b, where m is some number and b is some number. So I guess our b here is 5, but there's no mx part. There's no like 3x or negative 1/2 x or something like that. So first of all, let's graph this line and see what it looks like. If y is equal to 5, what we do is we come up to 5. That's our y-intercept. And then what I want you to think about is if y is equal to 5, that's really saying y equals mx plus b. If we were going to rewrite this, we would say that's the same thing as 0x plus 5. So y equals 5 is really saying the same thing as this second equation that I wrote here. This is the general form. This is y equals mx plus b. This is the specific case that we're dealing with here. So what's the slope? The slope is 0. That means you're going to go completely sideways. You're not going to go up at all, but you're going to run. So what we're going to do here is we're just going to draw a nice flat horizontal line. So we'll go ahead and draw our line here. By the way, another thing that helps people remember that when you have like y equals 5, that it's a horizontal line. A lot of people forget whether it's horizontal or vertical. I always ask the question, well, what's the y-coordinate? The y-coordinate better always be 5. And so if you pick a bunch of points on this line here, like here and here and here, what do they all have in common? The y-coordinate is always 5 at these points. Okay? All right, so that's the original line. That's not our line, but that's the line y equals 5. We're trying to be parallel to that. We're trying to go through the point 2, negative 1. So let's actually graph 2, negative 1. So 2, negative 1 is going to go right there. So we want to be parallel to y equals 5, and we want to go through that point right there. So let's just write this out. So y minus, so I'm going to do point slope form. So y minus y1 is equal to m times x minus x1. And in particular, the y-coordinate of our point that we're interested in is negative 1. So that's our y1. So we'll put that in, negative 1. That's going to be equal to the slope. Now, the slope that we have, as we said before, since it's not really pictured here, the slope is actually 0. So we'll put in 0. And then x minus, what's the x-coordinate of the point that we're interested in? It's 2. So we'll put a 2 in there. So we filled in the slope and then the xy coordinates. Let's simplify this a little bit here. So we're going to have y, essentially y plus 1 is equal to 0 times x minus 2. I feel a little weird leaving it like this just because of the 0 there. but I guess technically if you put it in point slope form, this is correct. I'm just going to throw it into slope-intercept form because it's going to make me feel a little more comfortable. Y plus 1 is equal to, if I distribute this 0 here, I'm going to have 0x minus 0, which is basically 0. So y plus 1 is equal to 0. And then if you subtract 1 from both sides, you'll get y is equal to negative 1. And I think this actually makes sense as our answer. So I guess technically that can be your point slope form right there. And this is your slope-intercept form. And if you come up and graph the line y equals negative 1, what will happen is it'll be a nice horizontal line running that way. So it will indeed be parallel, and it will go through the point 2, negative 1. All right, let's look at one last example, another weird one. So 5, write the equation of the line parallel to x equals negative 2 that goes through the point negative 4, 6. So let's graph x equals negative 2. A lot of people are like, wait, is this horizontal or vertical? Does this go sideways or up and down? What I do is I just start putting down points where x is negative 2. So give me a point where x is negative 2. How about negative 2, 1? So that's x is negative 2 there. Where else is x negative 2? How about negative 2, 4? Negative 2, negative 3, negative 2, negative 6, negative 2, 10. As you start to plot these points, you start to see, oh, right, this is a vertical line. So let's go ahead and draw the line. So here's our vertical line. And so we want to write the equation of a line that is parallel to the blue one that goes through the point negative 4, 6. So let's actually put that down. Negative 4, 6. Would be right there. It's that red point. So we're going to want a vertical line right through that red point. So how would we write the equation of a vertical line that goes through that point right there? Well, the equation of vertical lines is always of the form x equals some number. In our case, what does x actually equal for this red line here? What's the x value? Negative 4. So quite literally, this is just x equals negative 4 is the equation of the line. And that's not really in slope-intercept or point-slope form because it doesn't really have a y, because it doesn't matter what the y value is for this red line. X doesn't care. X is just like, I'm just always going to be 4. And so that's how we do those.